Alright, hell yeah. So what we're going to do is we're going to derive the kinetic energy equation. And I think we can do this fast as. We're going to use the approach that the units are the equation. I watched one video and I was like, no one's going to ever remember that. So we'll see if this is just dumb as. But anyway, so what we're going to do is we're going to drop just something off a cliff. Sweet. It has a mass. And we have a force on it of mg. You know what I mean? So we use F equals ma. And we're kind of starting from that perspective. But we still have to figure out what's energy. Kind of just the generic term is going to be force times distance. Okay, sweet. So it looks like, we got half of it right here. We could throw in ma and then maybe find, but anyway, so let's continue on and do this process all the way through, and then we'll see what we can actually put into here. So when we do this, we have a force of mg on a mass ma. And so this allows us to find our acceleration, and it's 10. Cool, 10 meters per second squared. Then I always love this, because you got zero velocity here, and then just run it for like 1 second. After 1 second, we're going to have a speed of 10 meters per second. And it's cool because we started at 0, got to 10, so we have an average speed of 5 meters per second. This would be like our average speed. And this allows us to find the distance we travel after 1 second. That's 5 meters. Oh, so booyah. So didn't we just find a distance? You know what I mean? Like right there. So it's pretty sweet. So now, like obviously the energy for this, we could find it in numerical terms. But I've been enjoying this process of like, hey, whatever I did to get this number, let's get an equation for that. This is why you shouldn't memorize the kinematic equations. You should be like, well, it looks like I found average velocity. But let's go back to, hey, we found velocity based on acceleration, and so we found that, and then we divided it by 2. And so then we got that distance. So we can say distance was that acceleration, 1/2 acceleration. Then I guess we did multiply by time. We took the velocity. We took acceleration, and we multiplied it by 1 second to get that. And so there was the first time thing. And then we divided it by 2 to get the average velocity. That's the half. And then we took this average velocity and multiplied it by 1 second to get this distance. Okay, so yeah, generically we have this. And our acceleration was g. So sweet. So our equation is just 1/2 g t squared. Okay, hell yeah. So that will be our distance. And then for our energy is going to be our force. Hey, is going to be mass times acceleration. Hey, times this distance. We know our acceleration is g, so we're gonna write mg. And then multiplied by this, 1/2 gt squared. Okay, sweet. So let's rearrange terms, and we got 1/2 mg squared t squared. Okay, but I don't know any of this, what this means. But I do know that the kinetic energy equation, I just, kinetic energy is 1/2 mv squared. I think we all get it, we just don't know where it comes from. So look at this. I want this to be velocity squared. So how do I do that? Well, maybe go back to what we did. What did we do to get velocity? Well, velocity, we just took the acceleration and then multiplied by 1 second. And so that was time. And so generically we have g times t. Okay, so velocity is g times t. What do I have here? Well, looks like I got 2 of them. I have 1/2 m, g times t, and then g times t. So sweet, let's input this into here, and we'll have 1/2 mv times v, and then we have the classic 1/2 mv squared. Cool. Now, I'm sure this is a dumb way to do it, but it's just satisfying knowing that you can, throw in one example with a number, and, kind of run through to get like a distance. That's going to be your change in x. And yeah, it's just you have all the tools at your disposal just very easily. I don't think I learned anything doing this. I don't think this is a proper way to do it. It was just fascinating just to be like, wait a minute, just force times distance? Well, I know all those terms, kind of, and I can just shove them in, and heck yeah. And so it looks like we got it. But honestly, I still didn't learn much from this. I just thought it was interesting, so I did it. But I'm going to watch more videos on how to actually derive kinetic energy, more from a proof standpoint. You know what I mean? I watched one video where they were using the equation of like V naught squared plus... I have no idea what's going on. You know what I mean? Those kinetic... I would never memorize any of them. It's like memorizing trigonomic functions that you're never going to use. But anyway, but maybe I should. Maybe I'm missing out. Anyway, this is a short video, and that never happens. So thanks for joining me, and that's a video.